Our last section, 7.6, is with natural logs in E. We've already learned common log. Common log is log of base 10, right? When we don't have anything there, it's a base 10. We also have what's called the natural log, and the natural log is actually log of base E, like this, okay? But we don't write log of base E. We have a different symbol for the natural log, and it's ln, right? So this natural log of base E would equal this. So whenever you have this, to convert to exponential form, your base is E, okay? And that's a button on your calculator, and if you notice on your calculator ln, second ln is e to the x, because those are inverses of each other. Just like the common base, when we have a 10 here, if you go second log, you should see there's a base 10 to some power, because those are inverses of each other. So all of these properties that we've learned so far in here, the adding logs, the subtracting logs, the log to a power, all of those properties take an effect because this is just another log, so those properties are going to work. A couple of specific properties to look at is natural log of 1, of course, is 0, because what's the base here? E, right? If I converted this to exponential form, I'd say e to the 0 power is 1. Right? That's the only way that would work. If I have natural log of e, that's always 1, because e to what power is e? It has to be 1. And then ln e to the power of x is x, and e ln x is x. These are two big properties that are on a poster up here. And the reason that happens, the reason ln e and eln cancel out is because they're inverses of each other. So what does that mean? That means if I had ln e to the 2, my answer is going to be 2. If I had ln e to the 5, my answer is going to be 5. If I had ln e to the smiley face, it's going to be smiley face. It's just a pattern. If you have ln e to any power, it's that power. That's what this property is saying. Ln e to the x is x. Okay? Same as the second property, e ln, just kind of reversing it. So if I had e ln to the 4, it's going to be 4. If I had e ln to the z, it's going to be z. If I had e ln to the ice cream cone, it's going to be ice cream cone, right? Just recognizing that pattern. That's what I want you to see there. Ways of solving: if I have the natural log, solve the natural log, or if I have the e exponential, how do you solve exponential? So we've gone over this quite a few times. The only way to solve a log is to do what? Convert it to exponential form, right? The only way to solve a log is convert it to exponential form. So when I have a natural log, do you remember what the base is? E, very good. So I would have e to the 6th power equals 3x. That's how you convert a natural log into an exponential function. Right? Oops, and it's 6th power, not x. These homework today, you'll need your calculator because E is on the calculator. We've used that button just a little bit before. So again, you can put all these steps on your calculator. Because what I'm going to do is I'm going to go e to the 6th power, and then I'm going to divide by 3. That's how I solve for x. To get x by itself, my final step would be divide by 3. So I can actually do that all in one step in my calculator. I can go e, so second ln, to the 6th power, divide by 3. And let's round to the hundredths on these. So my answer would be x equals 134.48. So if you look at the next one, again, natural log is isolated. That still has to be a step. If you have any other stuff, you'd have to subtract or add or divide over. Don't forget that. Okay, so all I have is a natural log here. So the only way to solve a log, convert it to exponential form. So there's really a base e here. So I'd say e to the negative 2 equals x. Right? So in my calculator, all I have to do for this one is just e to the negative 2. And I get 0.14. So we'll say x is approximately 0.14 because I'm rounding. So again, all I have here on the left side is a natural log. So again, I can convert that to exponential form. So again, it's base e. So I'd say e to the 36th power equals 4x minus 1. Okay. And again, you can do this all on your graphing calculator. You can take e to the 36th power. Then I would add 1 and then divide by 4 if you're going to do order of operations. You don't have to write down all those steps. You can just do them on your calculator. You should be almost there at this level of math. So e to the 36th power, and then what? Oh, I would add 1 over, so plus 1, and then I would divide by this 4 here, divide by 4 equals. And notice you have scientific notation. You won't want to write 15 zeros, so I would leave this in scientific notation. So I'd have 1.08 times 10 to the 15th power. This example, I have this natural log, but since I have this 1.1 here, I would have to subtract that over first, because in order to solve a log, you need just the log by itself. So I would need to subtract 1.1 first. So then all I have is this natural log. So 6 minus 1.1 is what? Now, once it's in, right now that I have the single log, I can put that in exponential form to solve. So again, there's base e there. So I'd say e to the 4.9 equals x squared. So on my calculator, I would do e to the 4.9, but how am I going to get x by itself? I would have to square root both sides. Yep. And I can do that step before or after. You would get the same answer. So I would have the square root of e to the 4.9. And I get 11.59. So x equals approximately 11.59. This is isolated because really there's like a set of parentheses right there. You're taking the natural log of that whole thing. Okay, because the x is subtracting 1 and being divided by 2. That's how you know it's part of the log. So I do want to convert to exponential form right away. So there's an e here. E to the 4th power equals that. And this is just getting you to practice some fractions, since we're going to be moving into that next week. Okay. How do I solve for x? I would take e to the 4th power and undo what first? I would times 2 first. So I'd multiply both sides by 2 first, and then I would add the 1. Right. So on my calculator, I can do that. I can do 2 times e to the 4th power, and then take that, add 1, and there's my answer. So I would say x is approximately 110.2 if I rounded to hundredths. Let's move down to number 26, because I think you guys are getting the grasp of this. What would I have to do first on 26? I'd have to divide by 2 first. You have to get the natural log by itself. So I'd want to divide by 2 first. That's gone. Now that I have it into a log, it's isolated, I can convert that to exponential form. So remember natural log, there's a base e there. E to the 1/2 power equals 2x squared. Now, if I'm going to solve for x, what order of operations undoing am I going to do? I got to divide by 2 first. Very good. Divide by 2 first, then what? I divide by 2, and then I'm going to end up square rooting. So if you want to do e to the 1/2 divided by 2 and then square root it, or you can do it all on one big mathematical sentence in your calculator. Either one, you should get the same answer. So I would do e to the, let me show you the other way, e to the 1/2, so 0.5, divide by 2, then I can square root that. So you use second negative sign, recall that answer, and you should get 0.91. So x is approximately 0.91. We'll do one more example here, 28. If you notice, again, natural log is isolated. Okay, so there's 2 ways you can do this one. You could go ahead and convert it to exponential form and solve, or you can take that 2 and put it in front. Both ways will get you the right answer. Did anybody see to put that 2 in front? No? Okay, so let's just, it's isolated, so let's just convert it to exponential form. So I'd say e cubed equals t minus 1 squared. So what am I going to undo first to solve for t? Square root, very good. So I'd square root both sides, and that would get rid of the squared, and then my final step would be what? Plus 1. So on my calculator, I would go the square root of e cubed, and then I would add 1. So 5.41. So let's look at some examples of solving exponential functions with e. We learned last section, if I have an x variable exponent on one side, what's the method that I use? Test on Thursday. You log both sides. Very good. So we're not going to log both sides. We're going to natural log ln both sides because we're dealing with e, right? When you're dealing with e, you want to use natural log, not common log, okay? So we're still going to log both sides, but we're going to natural log both sides. And if you look at the top of your notes, the reason we do this is I just created a property. If you look at your notes, the second to the last property, if I have ln e to a power, what's the answer? The power. So by doing this, I created this. Ln e to the x is x. Remember we went over that? Ln e to the 4 is 4. Ln e to the, ln e to the 10 is 10, and so on. That's a property that we looked over. Okay? So now I have this. X equals ln of 18. I can just plug that in my calculator. I have a natural log button. So here I'm going to go natural log of 18 equals, and there's my answer. So 2.89. Try another one. Yep, so you do need to isolate it first. Good. I need just the exponent here. So let's subtract 4 first. So I'd have e to the x over 5 equals 3. Now I can natural log both sides. And when I natural log both sides, this created a property. Ln e to the x divided by 5 is x divided by 5. Right? How do I solve for x? How do I get rid of this 5? Multiply by 5. Yep. So I'm going to multiply both sides by 5 to get x by itself. So again, on my calculator, I'll take natural log of 3. Make sure you close your parenthesis, and then multiply by 5. And I get 5.49. So again, e to the 2x all by itself, so I can go ahead and log both sides. So ln e to the 2x equals ln 12. Here's a property though, ln e to the 2x is 2x. How would I get x by itself? Divide by 2, very good. So on my calculator, ln 12, make sure you close your parentheses. Divide by 2 is 1.24. Examples here because you guys are getting it. Again, I need to isolate this e. So what do I do first? You're going to add 8 first to get it by itself. Right? And then what? I have an x variable exponent on one side, so I log both sides, but in this case it's going to be natural log both sides. And ln e to the x divided by 9 is x divided by 9. And how do I solve for x? Multiply by 9. Very good. So x equals, got to get my calculator out, ln of 14, close your parenthesis, multiply by 9, is 23.75. Let's do one more, the last one. In this one, I do want to get just this e to the x over 2 by itself. So there's 2 steps I have to do in this one. What are they? Minus 7 first, right? Because there's no sign in front of that. That's a positive 7. So I would subtract 7. And then what? Divide by the negative 2. Good. So now I just have e by itself, positive 3, because negative divide by negative. Now that I just have e by itself, I can natural log both sides. Ln e to the x over 2 is x over 2. And then to get x by itself, my last step would be multiply by 2. So I get out my calculator, natural log of 3 times 2 is 2.2, round to the hundredths. So x is approximately 2.2.